There's a concept when you're dealing with functions and their inverses called proving that a function has an inverse. In other words, proving that something I give you, like, I don't know, f of x, is actually the inverse of p of x. The way you prove something isn't to just do some calculations and show that you got it. Okay, that doesn't actually satisfy mathematicians, because when you get into higher levels of math, abstract algebra, when you're dealing with gigantic ugly matrices, there's actually a method used for proving an inverse relationship. And if you don't follow that exact method, you aren't considered to have proven anything. So we're going to get into a little bit of that here. Basically, we're answering this question: are P and F inverses of each other? So the way you do it is you do P composed F. We've talked about compositions before. And if the result is X, then that's interesting. If you then do F composed P, right, reverse order, and you also get X, okay, that is what it takes for something to be an inverse. Okay, and if you don't get that, then it's not an inverse. Now, there are situations in life. You'll notice that actually, if you get X in the first case, it's almost always going to be X in the second place. But not always. So this has to be a usually here, but not always. There are cases where you might get X in the first case, but not X in the second case. So be careful to prove them both. Now, let's go about actually solving this. Okay, the first question is, what's P of F? Okay, we've done this before, and it's going to be a little bit annoying, so I'm going to give myself some space. P of F, remember what that is. That's P with F in the inner parentheses. So to do that, I'm going to write the P equation. Okay, so P of F is this thing. I take my equation for P, which is 5 times something plus 3 divided by 2 times something minus 6. And in that parentheses right there, I'm going to put the F equation. So this is negative 6x plus 3 over 2x plus 5. And that goes in both places, negative 6x plus 3 and 2x plus 5. All right, so that looks terrifying. And the way you deal with this, the reason it's so ugly is because it's, fractions within fractions. It's just awful. So what you do is we have to get rid of those fractions inside the fraction. The way I'm going to do that is with a crazy 1. So I'm going to multiply this double-decker fraction on the left by 2x plus 5 over 2x plus 5. That's going to have the effect of canceling out those little denominators in there. So let's go through this one step at a time. Top left, and I'm going to circle this just so you know what I'm talking about here. I'm going to do this one times that. And here's what I get when I do that multiplication. The 2x plus 5 cancels out, so all I have is 5 times negative 6x plus 3. Now when I do the top right, that's not so bad. I mean, really, that's actually quite nice. It's just 3 times 2x plus 5. And then on the bottom of the equation, so now I'm talking about this guy on the bottom left. I'm going to take this thing and multiply that against 2x plus 5. It cancels out the little denominator, 2x plus 5, and all I get is 2 times negative 6x plus 3. 2x plus 5's cancel out, and on the right of the bottom, I have minus 6 times 2x plus 5. All right, cool. So this isn't so bad. I can simplify this by just breaking open those parentheses. 5 times negative 6 is negative 30, plus my 15, plus 6x over here, plus another 15, divided by what looks like negative 12x plus 6 minus 12 more x plus 30. Okay, so now we do a little more simplification, see if I get something that's just x. Doesn't look too good, promising at this point. Negative 30 plus 6 is going to be negative 24x plus 30 on the top, and on the bottom I have negative 24x plus 36. Okay, well, did I do some math wrong there? I did some math wrong, yes. This was supposed to be a minus 30. Okay, anyone catch me on that? It happens to the best of us. So that's negative 12x minus 30 because of this pesky little negative sign that I forgot to distribute there. Okay, fine, moving on. So that simplifies just a little differently. I mean, the main result is going to be similar in that I get this. Okay, I can simplify that if I want, but I can see this is not going to be equal to x, right? We're going to get something like negative 4x plus 5 over negative 4x minus 4. It's not x, okay? So as soon as I see that p of f is not x, for one thing, I can answer this with a hard no, okay? These are not inverses. And I'm going to take that negative 4x plus 5. I'm going to put that right here. So this composition is negative 4x plus 5 on the top, and on the bottom I had, forgot already, negative 4x minus 4. Now, you're not done until you actually show not only is this one not x, you also have to show this one right here. I'm not going to go through that in this video because it's basically exactly the same, except you switch f and p. So you'll do the same procedure again. You'll find something, I really doubt it's going to be x, and then you have your answer.